Section 3.1 is law of sines, and we'll be using the law of sines to solve oblique triangles. Oblique triangles have no right angles. Here's an example of an oblique triangle, and we use capital letters to represent the angles and lowercase letters for the sides. And so side A would be opposite angle A, side B would be opposite angle C, and side C would be opposite angle C. In order to solve a triangle, which means to find the measure of all the angles and the lengths of all the sides, we need to be given some information to start with. Depending on which information we're given, that would determine what method we use to solve the triangle. So if we are given the measure of two angles and the length of any side, that would be case one. Or if we're given the length of two sides and an angle that's opposite one of them, that would be case two. In those two cases, we can use law of sines to solve the triangle. The other two cases, we need law of cosines, which we'll talk about in 3.2. So law of sines just says that all of these ratios are equal. So side A divided by sine of angle A is equal to B divided by sine of angle B, which is equal to C divided by sine of angle C. And we'll only need two of them at a time. And based on the information that we're given, we'll determine which two of these ratios we'll be using. So jumping right in with an example, here we are given the measure of two angles and the length of one side. And it is all drawn here for us in a diagram. So to solve this triangle, we need to find the two missing sides and the one missing angle. So first thing I'm going to do here is find the missing angle. I know that the sum of all three angles in a triangle has to be 180 degrees. So 102 degrees plus 29 degrees plus my missing angle A have to equal 180 degrees. So I just need to solve this little equation for A. So the sum of the first two angles would be 131 degrees. To get A by itself, I'm going to subtract 131 degrees from both sides of the equation. And that's going to leave me with A being equal to 49 degrees. So I'm just going to start a little list on the side to keep track of what I know already. All right, so next I'm going to use law of sines to find one of the sides. And in choosing two ratios, I want to use one that I know completely. I know the side, I know the angle. And then I want to use another one where I know half of the information. So it's only one thing missing. So I know angle B and I know side B. So I'm going to use B over sine B. And then if I want to find side C, then I'll set that equal to C over sine C. So in this equation that I've made, I want only one thing to be unknown. So I'm going to fill in the things that I know, and I'm going to try to solve this equation for C. And to do that, I just would need to multiply both sides by sine of 102 degrees. So if I multiply over here by sine of 102 degrees, these will cancel. And I just need to multiply this out on the other side. Now, unless the problem is asking for exact answers, you're just going to put this in your calculator. Make sure that you are in degree mode. And you're going to multiply 28 times sine of 102 degrees and divide that by sine of 29 degrees. And we are going to, we'll just keep two decimal places here. And we should get 56.49 feet for side C. All right, so we just have one thing left that we don't know. We don't know side A. So we're going to set up law of sines, and we want to use one ratio that we know completely and one where we know one thing but not the other. So we want only one thing that's unknown. And it's best to use the given information as much as possible, so that way if you made a mistake somewhere in your calculations, that won't affect further calculation. So to find side A, I've got to use A over sine A. I'm going to set that equal to, I'm going to use B over sine B because both angle B and side B were given to me. So now I'll plug in what I know. We calculated angle A to be 49 degrees, so plugging that in here. And we were given 28 for side B and 29 degrees for angle B. All right, so now we're solving this equation for A, which is going to require us to multiply both sides by sine of 49 degrees. So multiplying by sine of 49 degrees over here, those will cancel. And then I have to do the same thing on the other side. So A is equal to 28 feet times sine of 49 degrees divided by sine of 29 degrees. And we're going to put that in the calculator, making sure we're in degree mode. And we should get to 2 decimal places, 43.59 feet. Right, and we have solved that triangle. We found all of the sides and all of the angles. Something that might help you kind of check and see if your answer is reasonable, that the largest angle should be opposite the largest side. You can see that's the case in our triangle here. Okay, let's do an application problem that uses law of sine. So here we've got a pole that is tilted towards the sun at an 8-degree angle from the vertical, and then it casts a shadow that's 22 feet. So I'm going to try to draw a picture of what this looks like. So the tilt on that is 8 degrees. There's the shadow. Shadow is 22 feet. And from the tip of the shadow to the top of the pole, there, that angle created is 43 degrees. Okay, so there's a rough sketch. Give me a visual on that. I want to know how tall the pole is. So my goal is to find this side here. All right, so I'm going to label these, and the labeling is not important here. Just call this A, this B, this C, as long as the, sides are opposite the angles, the letters A and A are opposite each other, B and B are opposite each other. Doesn't matter which angle you call what. So here, what I'm ultimately trying to find, the way that I have labeled the triangle is side A. So I need to use a ratio that involves side A and angle A. And then I want to set that equal to 1 where I know both the angle and the side. And for this situation, it looks like I know side C. We can't use this just yet because we don't know angle C. So let's see if we can figure out angle C. From this information that we're given, we can determine the length of angle B. So this vertical there, that makes a 90-degree angle with the ground. So angle B, it's got to be 90 plus that 8 degrees that the pole is leaning. Okay, so we got 90 degrees to the vertical, and then we're leaning out 8 more. So angle B is going to be 90 degrees plus 8. So we know angle A. Angle B is 90 plus the 8. So it's 98 degrees. So what is angle C? It's whatever's left over. So we got to take 180 degrees and subtract 43 plus 98. So that's 39 degrees. 39 degrees is angle C. Okay, so now we got enough information to find side A. So I'm plugging in things that I know. I know angle A. I know side C that was given to me. It's 22 feet. And sine of angle C, we just found to be 39 degrees. All right, so now we got enough information to find A. Again, we're gonna multiply both sides by sine of 43 degrees. This denominator here to cancel it. So A is gonna be equal to 22 times sine of 43 degrees divided by a sine of 39 degrees. And that's going to come out to be approximately 23.84 feet. So the pole is 23.84 feet tall.